In 1985, a new form of carbon was discovered called C60 or Buckminster fullerene, and it's got exactly the same shape as a football. We're going to make a molecular model of this in a second, but before we do that we need to explore the shape of a football a bit more. Now if you look at a football, you can see it's made of pentagon patches, which are 1, 2, 3, 4, 5, got 5 sides. And we also got hexagon patches, 1, 2, 3, 4, 5, 6. Now there are 12 pentagons on the football, and each pentagon's got 5 edges and 5 corners. Now it's not obvious, but actually if you spend some time looking at football, you'll see that there's no corners that aren't actually in a pentagon. So if you count up the number of corners in the pentagon, that's 5, times it by 12, the number of pentagons, we've got 12 times 5, which is 60. So it's actually the number of corners in a football is 60. So if you put an atom at each of the corners on the structure of a football, you'll get the molecular structure for C60, which is why it's called C60. So our next job then is to use our molecular kit and actually make the model. So this is the pack that you've got. In it there are some little black atoms that you can see here, and these have 3 legs on it. And on these black atoms you put the straws, and we've got some red straws here which we break off, and we can get a single straw from that. And we've also got some white straws. Again, we break these up and get the single straws out. And we use the black ones, we join them together with the red straws, and we're going to make a pentagon, because if you remember the football's got 12 pentagons. So we join up 5 straws with 5 black atoms, and the straws will want to make a hexagon, so you just bend them to form a pentagon. And there you've got a pentagon. 1, 2, 3, 4, 5 sides and 5 black atoms. So we need to make 12 of those to make our molecular model. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we take our pentagon and we add one of our white straws. So we're adding just one bond and then another one. So we've used up all the red ones now, and actually we've used up all the black atoms. So now all we simply need to do is to start joining the pentagons together using the white straws. So we're sort of making a little man like this. And then what we can do is we can start joining these up, these up, these up, these and these. And this is the nice bit, because now as we join these up, what looks like it's going to be pretty flat and uninteresting starts to curve up. You can see that the thing's coming off the table, and we're going from a flat sheet to what looks like half a bowl. So you can see you've got something that's bowl shaped now. So we do the same, we put that aside and we put another one down, and we can do the same. Now there's many ways that you can make a C60. I'm going to make 2 halves and join them together, but you don't have to do it this way. And you've got another bowl. So we've got 2 halves which can join together to make the football. Okay, now all I need to do is fit some bonds, the white straws, onto the 3 legs of 1 half, like this. You'll see that in the kit there's a few extra bits. And then I can start to join these two together. And you just got to make sure that you join them into the right places. So you want to join them up so that you get a hexagon here. And then you simply zip it up. And there you are, you've got your buckyball. Really, if you see here, what we need to do is join this together. And that's how the hexagons form. But what can happen if you're not careful is you can try and join another pentagon in, a bit like this. And that's obviously wrong, because if you count up, it's got 1, 2, 3, 4, 5, 6, 7, 8 sides. So that's an octagon. So that's not right. So what you need to do, it's very simple. You've just got to remember to always join them across to make a hexagon, not an octagon. So this is the completed model. It's got 12 red pentagons, and the hexagons come about just by putting the pentagons in the right place. We've got 60 black atoms, so this is a molecule, or model of the molecule of C60. The real thing is very, very tiny, so it's about a nanometer across. So that's a billionth of a meter in diameter. And it was named after an architect called Richard Buckminster Fuller. So sometimes it's called C60, sometimes it's called Buckminster Fullerene, sometimes it's called a buckyball for short. So this is a model of a buckyball.